Yes, and also we're going to talk about why I give insanely long titles to things. Yeah, so I will just switch to the next slide because I think nobody can focus with the dancing gophers. That might have been a bad design decision on my end. So nice to meet you, everyone. I'm Daniel. I work as an engineering manager by day, and during nighttime I write Go code and maintain my open source repositories. And you can see that I'm a very back-end focused person. This is why the slide design is so amazing. But as I am a very visual person, before we deep dive into what I'm going to say, let's take a look at what this whole stuff is actually about. So no live demo today. So what I basically did is I wrote two libraries that allow you to use iOS devices on Linux machines and also Windows. So, and what does use mean? So if you want to automate anything on iOS devices or run tests, right? So I was thinking maybe some developers, you know, they write UI tests and they have a Linux box around and a bunch of devices, and maybe they want to run their UI tests on a Jenkins or a CI, right? And not buy or maintain Mac servers for that, because macOS is also pretty expensive. I mean, Mac minis, right? So you can do this on a $100 Linux machine. You don't need to buy a $1,000 Mac. And what you see in the demo is both of my open source projects combined, right? So you can see here the iOS command runs an automation agent on the device now. And in a few moments, I'm going to execute a little testing script that will run a UI test on the device. The test in this case is written in JavaScript with WebDriver IO, which is a fairly popular automation testing framework. And as you can see, so what it's going to do is it will open a YouTube video, then it will wait for 5 seconds, and then open the weather app. And because this would be pretty boring, right, because you see a screen recording, and when I did that, I had an actual iPhone connected to the Linux box, but you cannot see the iPhone in the screen recording, of course. And so that is why I built a second project that lets you screen mirror iOS devices on Linux. Usually that only works with macOS using Quicktime, but I found a way to implement it. So now we can witness the test running. And like I said, the cool thing is, right, this works on Linux and Windows, and you don't need Macs for it. So if you have a little device fleet, 30 devices or something, then you can use those frameworks. And so this is what it does. And the talk is going to be about the first part is how do you get there? How do you build that with Golang? And the second one is how do you maintain an open source project? And you can see me being excited because it actually works. Okay, thanks. And then back to the presentation. So the story of QVH, right? You see I'm super gifted at naming talks and projects. So when I built this, I had no clue what to call it, and because on macOS this works with QuickTime, you know, I called it QuickTime Video Hack, which is, well, anyway. It's an open source project, and like I've seen quite a few people use it. It has some traction, but let's talk about first, so where does this come from, right? So what is this? So like I said, right, so this is what you can do on a Mac. You plug an iPad or an iPhone into your computer, and with QuickTime, you can record a high-resolution video of its screen contents and also audio to, I don't know what, record your screen. And so the goal was, let's figure out how they actually built that and then reverse engineer it and then use Golang to build the same, just for Linux and Windows. So how do you do that? So as every good developer, the first idea is we Google it. And then the cool thing is, I found a video on YouTube where somebody posted just what I posted, right? They already had it working. It was on Ubuntu, so nice. So you know, you scroll down to the comments, and then you see 20 people asking for the code and no responses. It's like, Then you keep Googling and you find forums and discussions, but nobody has a solution, no source code. So, well, the only option left is, so how hard can this actually be? And generally, when you reverse engineer things, there are two methods that come to mind how to do it, right? So the first thing is you can take whatever binary is doing this, throw it into a disassembler, and then you will get some kind of C code like this, right? Some pseudo code, and then you try to understand how it works. That's pretty hard, though. So I was thinking, I mean, I've done that before, and I actually done a lot of that, but still it's like, So I was thinking maybe we can just take a look at what actually is being sent over the USB port. And now the cool thing is that Wireshark actually allows you to do that. So if you take anything away from this talk, if you ever want to reverse in a USB protocol, with a Mac, you can totally do that. Just run this command, open Wireshark, and you're good to go. And then you do that, and you get this, a beautiful hex dump. And then now you might wonder, so what is all of this? You see a couple of strings, but they don't make any sense, and then there's some data, so how are we ever going to turn this into a video? So let's start. We go back to networking basics and computer science school. How do you actually send messages over streams? There are not terribly many options, right? So the first thing is you can have fixed length messages. So every message is like 10 bytes. If we look at this hex dump, that doesn't work because there's no repeating pattern here. You can have delimiter-based messages, right? They always have the same 5 bytes, then something else, and then the next one, right? So logging would be a good example. They always end with a line break, so you can easily see that. In this case, it's the other one, where usually what you see is you get 4 bytes. So this is an unsigned integer, and that one contains the length of the payload, right? So what you do is you read 4 bytes, then you put it into an integer that says like 17 or something, and then you know the payload. And if you look at the hex dump, it nicely aligns. So we can see that we have 2 GNIP messages, whatever that means. So then you're like, what the hell is a GNIP? And then you think about byte ordering. Right, it's okay, this is going over the network, so you need to reverse everything because it's little endian. And then you reverse all the strings, and then it suddenly makes sense. So it's a ping. And you can see that this is actually a handshake. So you connect the device sends a ping message, you send one back, and boom, here we go. And then you go down the entire rabbit hole, you reverse all the strings, and you're trying to guess what they mean, right? So you see like an async, okay, it's probably some asynchronous call, feed, that sounds like something video, and so on. And they even have their own dictionary stuff in here. So, and that way, you spend maybe 2 or 3 weeks going through a hex dump, and because what else are you going to do on your weekend? And then you find this, right, the fubs, or in this case, sbuff, and then you Google it, and you see, interestingly, sbuff is the favorite variable name for anything CM sample buffer, which is a core media framework class. And like, oh, interesting. Let's look at the header files, and then you see they nicely align. So this is actually a serialized class, and then you go through, you decode all the properties, you write your own codec, and this one is particularly interesting. This stat, I guess it's streaming data or something, and you find that this one contains raw H.264 network abstraction layer units, so basically raw H.264 frames. So if I just extract all of these and write them to a file, will I be able to play it? And turns out, yeah, that's exactly what you do. So you extract all of these. That was the first version of it. I extracted all of them, wrote them to a file, and I heard a great talk about Tokyo today. And yes, you read a lot of RFCs, right? So I read the entire H.264 RFC to understand how all of that works. And then I found this. You can just do a delimiter-based protocol here. So you write a 1, then you write the raw NALU, then you write another one, and you keep going. You put all of that into a file, you double-click it, and boom, you see a video. Nice. That was the short version of how this worked. In reality, it might have taken me a bit longer, but let's move on. So why do I think Golang is great for doing stuff like this? First of all, working with USB devices is really easy with the Go USB package. So if you want to tinker with a USB device or communicate with it, check out this package. It's really great. Right, you can see basically you make a few calls, and then you have a stream, and you can send binary data to the device and receive binary data back. Why is Golang great for this? So I used to be a Java developer, and I never really understood why they didn't include unsigned integers into the language. So in Java, if you have a 64-bit integer, a 32 unsigned bit integer, you always have to cast it to a long, so a 64-byte integer, and you're like, why did they? I don't understand. And with Golang, this is much easier because you have a type for everything. So if you write anything networking or low level, this is perfect. And then also byte slices, I found, are a true blessing when you write these codecs, because they just come with the language. So I don't need any fancy buffers. I can really just do it like that. Write an integer here, and this way I can build my message. And last but not least, you can even write structs directly to streams, like in C. This is so amazing. I mean, if you've never written Java, then maybe you're not feeling the pain, but this used to be much harder. So now I have a simple Golang struct, and I basically just copied this from the Objective-C definition, and I'm writing it directly to the stream and to the device. So much easier. So the summary of all of this, right? I know it was a bit quick, maybe. I think reverse engineering makes you a better engineer, and I think you should at least try it. Why is that? First of all, I think you need to go through a lot of theory, right? Like you think about, so how could they have built it? I mean, there's a finite way of how things can be built, and if you want to reverse engineer something, likely the other engineers chose one of it. So you make some theories and you try them, and maybe you'll find it. Then actually writing unit tests was really important, especially when I wrote the decoder part, right? Because reverse engineering is kind of tricky, like you don't know how it works, so you build it as you go, and then if you have basic mistakes in your decoding pieces, that will just make your life much worse. So good opportunity to work on your testing skills. And then you learn many new cool things, right? Like you remember networking basics that you might have forgotten. You learned that at some point, but it was interesting. You read specifications, you learn how H.264 works, which is cool, USB coding. And at some point I was even able to read hex dumps of WAV files. And I knew, this is a WAV file and here's, anyway. And last, so I like low-level stuff, right? So because there's no magic, actually. So if you ever wondered, what is a PNG file, actually? And then you read the specification, and you're like, oh, a PNG file is just basically a byte array that starts with a signature that says, I'm a PNG file. And then there's a table that says, now comes this data, now comes this information. And so on the low level, everything is actually very simple. And plus, you get a lot of love from people if you do cool stuff, right? So I saw some person in China, they actually built like an entire product out of this. So they have now a screen recorder, but they were really cool. They told me, or they explained to me how to do it on Windows because I wasn't able to figure it out. Okay. So now off to my second project, and we're not going to do another technical deep dive, so I spare you the details of that. Although, should you be interested, I can talk about this for hours. As you can see, my naming skills have not improved. So why did I call it Go iOS? Because in 2018, I was at this conference, and I wanted to learn Go, and I thought about starting this library. So because it's written in Go and it does stuff with iOS devices, I called it Go iOS. And since then, so since 2018, actually this became really quite famous. I have a lot of big testing companies use it for their services, right? So there's like companies out there that have thousands of devices in hardware racks, and they sell it as a service. And for those, of course, it's super cheap if you can do it with Linux at scale. And also many more interesting use cases, which we can talk about later maybe. I bought a cute logo, right? So I was inspired by Go. And I just want to talk about some design considerations that I made when writing this tool, because I think they are universally applicable. So first of all, the tool was written in Go, and why is that good? It's the way it's shipped, it's a command line tool, and I think Go is really cool for building these. Because, like I said, I was writing Java before, and if you wanted to ship anything Java to a customer, you would be like, please install this 15 gigabyte JDK, and then download it from there, and then click yes 15 times, and please make sure you have the right version also. And here's the 500 megabyte Java executable that you can run with this 59 character command. And of course, replacing it with, well, type iOS and enter, and then you will see everything is much cooler. Also, it's just much faster from startup times. So I think Go is a really good choice if you write CLI tools. Then one thing that annoyed me with other tools that do something similar, they always had human readable output, which of course sucks for most people because they want to automate it somehow. So Go iOS outputs JSON by default. So you run it, you get JSON, and you can use it from JavaScript or whatever people have. Also, it uses stock-opt, so it's an all-in-one binary command, right? I type iOS list, I get a list of all devices. I type iOS screenshot, and it makes a screenshot. I type iOS run test, and it runs a UI test. And this one is actually interesting. So I hate Brew like nothing else. I don't know about the people here, but still, I wanted to have some package manager support. I went with NPM because I thought everybody has it normally, and so this is how you can install this now. And you might have seen on the metrics, like I have, in good weeks, I have like 4,000 installs a week, and now it's like 1,500 currently. So somebody's definitely using it in the CI. And yeah, I like convenience, right? So many commands I build, they automatically configure stuff or make it very easy where it used to be very hard. So for example, to get iOS device ready to do all of this stuff, you have to look at the version and then download a developer image from Apple, and then you have to install the right one. And I just added a command that does that automatically. So you just run iOS image install, and boom, the device is ready to go. And some other things that I like to do. That one was also funny, right? So I was thinking, okay, you build everything as a Go module, so all the millions of Go developers out there who want to automate iOS devices, they will just be able to import it into their code. Surprisingly, most people just use the CLI tool. So yeah, but still it's very modular. So I have some Go users actually doing stuff with it. I built some cool tooling around it so people could actually develop it themselves. So there's a debug proxy that allows you to extend the library yourself. So you don't have to be necessarily a reverse engineer. You run this, and it will tell you which commands you need to add to the library. And last but not least, it's MIT licensed. I think that was a good choice, although I definitely know that a lot of companies are using it, and they're not paying anything. And believe me, I asked. But I mean, that's just the way it works, right? Like if you go MIT licensed, this is a risk that you have to take, but it definitely helps with adoption. So that's also something I see, right? So many people are afraid of more prohibitive licenses. All right, now let's go to the Golang part of it. Pitfalls. If any one of you is a not so seasoned Go developer, here are some pitfalls that I learned the hard way. As many other developers coming from other languages into Golang, we like to apply patterns that we know to Golang, and it turns into horrible code. So of course, my first version, as I was a former Java developer, was like 5,000 files, and everything was in a struct. So once I'd learned that you don't do that anymore, I wrote a lot of Netty code. So if maybe any Rustaceans are here, Netty is like something like Tokyo, just for Java. So it's asynchronous networking, basically. So I thought, well, that would be awesome, you know? So it's basically everything you can do wrong with Go. You come into the language and you're like, oh, there's Go routines, nice, and we have channels, I gotta use all of it, and build my own asynchronous network framework. Great idea. So you spin up a Go routine, it reads constantly, there's channels, and then you end up with horrible code like this, where like at some point you need to switch decoders, right? So there's a network codec that reads something, and then you need to switch. So try to do that if you have this asynchronous mess implemented that I did, right? So I added a function that would stop the Go routine, stop reading after next message, then I send something, then I wait for the response in the response channel, then I change the codec and I start reading again. Yeah, so this is how I did it then, replacing all of that, and was like, okay, maybe synchronous code just works, because this is a request-response pattern, Daniel, so, you know, keep it a bit low with the over-engineering. A fatal misconception. I don't know if anyone else on this earth has run into this, but for me it was mind-blowing. How the hell does a log statement always exit your program? And so I had this in a bunch of tests, you know, because I felt, yeah, log fatal, that sounds good. And I didn't understand why is my database not being cleaned up? Like, why are there so many files left? And I was like, what does this statement actually do? So I go into the code and I'm like, it exits the program, really? And I think I even had it in the library itself, right? So it might be that I crushed a couple of people's code with that. So that was one of my other newbie mistakes. And yeah, so defer doesn't work if you do this, right? Because it really like exits the process literally. So be careful with log fatal. Cgo. So Cgo can be really cool with stable maintained libs like GoUSB. In any other case, welcome to hell. You just entered a world of pain. I tried to use GStreamer, which is a media framework, right? So after having reverse engineered this whole Quicktime stuff for like maybe a couple of months, I thought that was the hard part. And the hard part actually turned out to be trying to use Cgo to actually display this in a video from a Golang binary. Still doesn't work today. And I created my own fork of a fork to make it work, because nobody maintains GStreamer Cgo APIs. And then you end up with memory leaks that you cannot debug because they're happening in native code, and the Golang runtime doesn't know about it. You have weird sec faults and errors, and yeah. So bottom line for me, if you use Cgo, either make sure that it's a very like mature library that is really well maintained, or just don't. And this one also bit me pretty hard. So panic and recover are not global, and by global I mean, so if you used to Java or Node.js, where you have like a global recovery thing that catches everything, in Golang it's not the case. In Golang, if you want to recover from a panic, you need to make sure that you do it in every Go routine, right? Because there's no global recover. So if you forget it in one and it crashes with a panic, then goodbye program, which is especially problematic if you're a library developer like me. So I definitely killed a couple of people's setups with this. And then something I also really don't get about Go is that there's a lot of, so when you access maps, right, you have a real high potential to create panics if you don't know because you're new to Go. So this one, for example, right, this will just panic, boom. Even if you add an OK here, it will only check if the string conversion works, but if the thing is not in the map, it will still panic. And now Go iOS does a lot of map string interface, and then it extracts another interface, so there's like a ton of this code in there, and I just forgot sometimes to check if it was actually OK. This one is new. I don't know if anyone knows that, anybody knows that. So coming from Java again, right? I'm used to stack traces, so I just put an exception somewhere and I get a huge stack trace that explains everything. Not so much with Go. In the beginning, I just returned error everywhere without doing anything. And if something fails, you get a string that says the file failed to read. And then you're like, where? And so I learned now that you have to add context to your errors, right? So you have to wrap them actually in something like this, where you explain, okay, here's where the error happened. This is what the error was, and so you can later actually understand which method was it that this stuff failed in. So yeah, that was new to me. And then yeah, this is particular to the library. Make sure people don't delete their friends' phones. So I built a new feature that was able to erase phones. And I think I designed it a bit too optimistically when I just let it erase the first device it found if you didn't specify an ID. So this was the first feedback I got. And then we're coming to the end. Being an open source maintainer is awesome, and I think you can do it too. So if you ask me, Daniel, are you ever going to learn Rust? Then I'm going to tell you, well, I don't know. If I find an interesting problem to solve, I might. One thing, I don't know if it's a junior engineer or a senior engineer thing, but one thing I really always recommend is if you want to learn a new language or learn something new, try to build something that's actually interesting. I think nobody on this earth benefits from the 50 millionth web REST API Rust example. Right, so pick something that is actually cool, and don't just follow a tutorial for a month and put it on your GitHub and expect people to care about it, because they won't. And the next, that was really harsh, I know. But the next one is build a community and be accessible. Building a community was actually really cool. Like, you put up a Discord channel and you would be surprised how many people show up, right? Like from all random places of the internet that you would never expected. Like I talked to CTOs of companies, I talked to Indian developers selling device automation. It was really interesting. And then be friendly and kind, right? So I'm very friendly, like even when people add a PR that adds linting to the project, and you're like, well, thank you. That is really what I needed, linting. Practical tips too. Look for sponsors, right? Don't be shy about it. I mean, you can totally do that. If you see somebody uses it, that should be the first question you ask, right? It's like, hey, how about a $1,000 sponsorship? And you just wait, say nothing, and see how they react. And so I'm not getting a $1,000 sponsorship, but I get some. And then look for contributors. That's something that I did a lot, and it actually worked. So now I have a team of developers from one of the testing companies who are really fully committed to helping me with this, which is amazing, right? Because I don't have to do everything myself anymore. And then, yeah, if you use MIT, just accept the fact that people will copy your code. There will be copycat repositories. Companies will use it. Some of the copycat repos even have more stars than yours. Well, that's how it goes. Yeah, and then the other thing, try growth hacks. It's fun, right? Like you read about all of this in product development books. If you have your own project, you can actually do it. So what I mean is, I was thinking about adding a command, right? So that was I was away with the family on the Easter holidays, and the kids were, finishing up dinner, and I was getting the movie ready, and I was like, let's add a growth hack quickly. So I added a command line command to Go iOS that literally did nothing else than print, if you really want this, create an issue. And it really took like 20 minutes for someone to create that issue, which was really cool, right? Because you can actually see that people use the stuff. And another practical tip is create content, something which I definitely need to do more. But the YouTube video I showed you actually attracts people to the repository, right? People find that, and they come into the Discord community through that. And I think this one is important, right? So it's like, Daniel, when the hell do you do that? So you have the day job, you have this. And I'm like, yeah, so easy, right? So I do it at night when everybody else is sleeping. When my wife is driving and trying to talk to me, I write code. She loves that. I go, what? Oh, yeah, so yeah. I wrote some code at night when I was drunk. The results were, let's say it worked, but I refactored it later. And it's hard sometimes, right? So you need to sometimes also just take a break. Like there were weeks when I did nothing because I just couldn't see that stuff anymore. So accept personal limits. What I get out of it and what it taught me. So I think this one is kind of cool. If you're an engineer, I think sometimes you might lack this whole product dimension, right? So at work, you might fight with some manager because they want you to implement something, but you think, no, I want to refactor this. And if you have your own project, and like I said, you do it on a very limited time frame, suddenly you start making these decisions yourself, right? So I look at the code, I'm like, this code is really crap, but it also works. And there's an issue that I really should be working on, or maybe I want to add a new feature, right? And you start making these decisions yourself, and suddenly you find you understand product decisions maybe way better than before. And yeah, I mean, that's what I am, right? So, I mean, I'm the core maintainer. I write the code. I do the product work by thinking of what should I add, what's missing. I'm also the business person, so I talk to people, right? So we have a lot of calls, and then you try to sell it, and you try to get some sponsorship out of them, and so that's all the time you invest. But it's also really fun. So it's almost like a mini entrepreneur. Seeing other people contribute is absolutely beautiful. So like I said, right, I built this Quicktime thing, and again, right, like I always imposter syndrome, and I'm thinking like, who the hell on this earth cares about that crap? And then out of nowhere comes this person from China, and they go, yeah, so we built this app, and here's the link, and it's based on this, and if you want to do Windows, here's how it works. And you're like, wow, this is cool. Like people are actually using this stuff. Or somebody out of nowhere, I get a PR where someone adds Wireshark compatible PCAP network capture. I'm like, okay, cool, thank you. And so yeah, building something that people actually use is really awesome. Yeah, the use cases, man, like it's, yeah. So when I built this, I was thinking maybe someone wants to put an iPhone on a Raspberry Pi and have some automation or something, or maybe have, like I said, right, some developers want to do CI testing with it. In the end, you talk to people. And so one day on LinkedIn, somebody pings me from a huge American insurance company. And he goes like, yeah, can you add these 2 features? We can also pay you for it. I'm like, yeah, sure. But what the hell do you do with that stuff, right? And they go like, yeah, so we have this process where we get millions of devices sent in from customers, and we have an automated check tooling that makes sure that these devices still work and that they can be repaired, right? And they use that kind of tooling for it because also for them, doing this on a large scale on Linux machines is way cheaper than Mac or Windows. And I think my favorite use case was, so the guy was a bit secretive about it, and at some point he goes, so, but you know, you're cool about this, right? I'm like, yeah, sure, whatever. I mean, I don't care. And he goes, yeah, so what I do is I run a farm of devices that I sell for OnlyFans advertising. So if you're an OnlyFans model, what you can do is you can buy the service, and the devices will go to social media, and then they will post on behalf of yourself, right? And like make the ladies look better or whatever. So, yeah. Closing comments. So what's going to happen next? iOS 17 support is coming up. Apple decided to sadly completely change how everything works. So good is that I have some help now, but yeah, it's still a lot of work. Next up, the library is going to get a REST API. So you can even use it more easily from other languages. And I probably need to write some blog post or something. And then I will conclude the talk with a call for contribution. So if you are interested in fiddling with devices and low-level code, definitely your pick. But even if you're not, you can also contribute to open source, right? So you can help out fixing my early day Golang mistakes. So like I said, right, there's a lot of error handling that isn't really great. There's a REST API that I want to build. Or maybe just writing documentation or be engaged in the community. There's a ton of options, and I can definitely need all the help that I can get. So yeah, if you're interested in this or in general nerd about Golang or devices or reverse engineering, you can also seek me out later. And that was it. Thank you.
Thank you so much. Thank you. Does anybody have any question?
Thank you very much for the talk. That was very inspiring. But like, if I resign from the company someday, they will be still live out there. Oh, it's great. Have you tried to hack this like LED, like RGB LED stations? You know, like which can kind of I bought a Core Light once, and there was a problem that it had a set of predefined like lights, like firework or fire or just a rainbow, but I couldn't make custom ones. So have you ever tried to hack this
No.
sort of stuff?
No, RGB LEDs, no. I have hacked I think there's a blog post somewhere. I have hacked a USB missile, like one of these desktop missile throwers launchers, because it was only working on Windows, and I also wanted a Linux version. Similar tooling. But I don't know if it's USB connected. Then you can also just get a USB dump and try to do it yourself.
Yeah, I think it used some like Wi-Fi connection.
Yeah, Wi-Fi. I mean, then maybe just regular Wireshark is good enough, right? So usually that's the good thing. Usually these hardware vendors, they're pretty bad at security. So, you know, it's oftentimes unencrypted or, you know, some, I don't know, rotation 13 encryption, pseudo encryption.
So you basically mean that I can like search for the traffic and like, find the IP of the device and just send stuff to this API and the IP, and it will work.
Depends on how it's implemented, yeah. But if it communicates over Wi-Fi, I don't know. Maybe they have a custom protocol, but probably not. I mean, probably it's just some REST or JSON-based stuff. Yeah.
Thank you.
Sure.
Okay, I think that's all. Thank you so much, D.Paulus. Thank you so much.
Thanks.